Today I'm looking at this paper, Auto-ICL in Context Learning Without Human Supervision. This is a paper out of Microsoft Research from November of 2023. And the important idea here that they propose is that you can get the benefit of in-context learning without any of the manual effort to curate the context that you will be sending to your language model. So they draft up a diagram here to show off the main technique, where they say you take a question with a prompt, send that to the language model to generate demonstrations or instructions, and then potentially send that off to a retrieval database to go grab real demonstrations and augment with those. Then send the question along with the synthesized or retrieved demonstrations and instructions and get an answer out of the LLM from that. And they show that across a few different data sets, they actually yield strong performance improvements, standing up well against existing methods. So the key benefit that you're getting with this is that you don't have to actually generate and find examples for your in-context learning. And they show here that perhaps if you have some input, such as if 3 girls join 2 girls to play a game, how many girls are there? The first step is to generate similar questions with answers. So the language model does not attempt to answer this question at this point. Instead, it will generate, here's question 1 that is similar to the original question, along with an answer that goes with it. And the expectation is that by providing these synthesized examples, you're actually going to get your language model to start reflecting and thinking about how to answer this type of question. And then they show that you can actually hook this up to a database to grab demonstrations as well, so that you don't have to only work on synthesized demonstrations. You can also have retrieved demonstrations. They show as well that instruction generation is a key part of this. So given a query, write the instruction that will properly answer this query. When we go back to the original example that we were just looking at, here's the question. Perhaps we should include an instruction that says, accurately answer the summation below. And if the instructor can write that out, that will help the language model figure out how to answer this. So they go into detail about the actual techniques that they use here. And they describe an iterative approach, an explorative iterative approach in particular, where they will test multiple instructions against the data set to find a good version to run the actual tests with. And then they show a classic results graph here, or tables showing that if you zero shot, on some of these, your average score is going to be around 38. Whereas if you add in chain of thought, you bump up all the way to 64. And then using their auto and context learning, you can get another 4 points on that, up to 68. But clearly this is not perfect. It's not always going to be better. The others here mentioned is just a general catalog of other data sets. And on some it might work better, and on others it won't. Then they also talk about an ablation of the various techniques that they use. So for example, generating demonstrations and instructions or generating them separately. And they show that in general, it is better to generate both the demonstrations and the instructions, not just the instructions or not just the demonstrations. So the only other thing to mention with this is that they actually open source their code base, and the implementation for this is not all that complicated. So they describe their main provides a whole list of arguments to configure it, and then that just pulls in the API that is a wrapper around OpenAI and a template to set up your automatic in-context learning. So this is pretty cool work in that it's very easy to work with. It seems like it will generate good demonstrations to actually work with and provide you with an improved result on your in-context learning task. All right, thanks for watching.